Hello friends and welcome back to laptop repair case study. So here we received a motherboard for repair. So I received this motherboard from another repair shop. So the repairman forgot to give me the adapter cable here. So I have just connected to the adapter line through a wire so I can connect it to the power supply and I can use any ground potential to complete the circuit. So I can check everything from these two wires. Okay. So and also I have just connected the power button line, so in order to check whether I'm getting certain voltages when I press the power button. Okay, so you can see the model number, the part number is LA-A994P. So basically this is a standard laptop, so this is not a high performance laptop, so maybe we should have a Intel processor here, which is I mean the Pentium processors. Okay, so let us see whether we can fix this laptop today. Okay, so the display of the power supply is visible to you now. Okay, so let me connect the power cable here. Okay, using the alligator clip. So let us keep it aside. Okay, the ground potential on this side here. Okay, now it's drawing around 10 milliamps, so that is fine. So let me check whether we have main power rail first on this motherboard. So we can check on this capacitor here. Yes, we have 19.63 volt. So that is perfect. So if I press the power button, okay, the LED is blinking on this side. You can see the LED is blinking and the ampere is drawing around 22 milliamps. So there is no much improvement. So the light went out again. So let me press it again. So I'm sure with this ampere reading, so we should not get even the RAM voltage. So it should be somewhere around the always voltage. Okay. Anyhow, let me check. Yes, we have 5.2 volt, 3.4 volt. Okay, 3.3 volt is there. And we don't have a RAM voltage. So this is the RAM coil. We don't have a RAM voltage. So this is another coil, so we don't have any voltage there. So this is probably the CPU power supply voltage. So these two coils are for CPU power supply. Okay, so we don't have a RAM voltage. Okay, so I forgot to check the diode value for all the coils, so I'll just disconnect the adapter, turn it to diode value. Okay, checking from the main power rail, from the current sense resistor line to each of the inductors. Yes, 520, that is very good. Yes, very good. Yes, 900. So this is quite high, but that is okay. So if it is high, that is no problem. But we should see around 500 or 600. That is the appropriate value. Okay. This is 500. Okay. And this one is 600, 500. Okay. And this is also okay. And here we have another small inductor, and that is also 600. Now let me check with respect to ground. So what about this? This is for the battery coil, so that is also okay. 56 is fine. 44 fine. 373 okay, that is also okay. 110, so that is fine. So we have a RAM module in the socket, so the reading will be lower. So if you remove it, the reading will be higher. Yes, 490. If I reinstall it, yes, you can see it went back to 100. So that is normal. Okay, yes, everything is fine. So then why are we not getting the RAM voltage? So first of all, we need to find what is this for. So what does this coil doing here, and on which stage this voltage will be generated. So we need to open the schematics to understand this and see whether we can find anything. Okay, so this is the schematics of this motherboard, so which is LA-A994P. So let me go to the standby IC. So from that we can start. So first we need to know whether we are getting a power good signal from the standby IC. Okay, so I'll just go to the standby IC. Okay, yes, so we are getting the voltages, so we don't need to check the enable signal for the standby IC, but we can check whether we have the SPOK, which is standby power OK signal. So let me check. So we can check it on pin number 6 here on the standby IC. So if I search it, so okay, so we have the timeline sequence here, so that is really nice. So EC on comes first, then 5 volt, 3 volt, SPOK. Then we have 1 volt always, then 1.8 volt always. So these extra voltage should be produced before we press the power button. So we didn't find any voltages on this motherboard as 1 volt or 1.8 volt. Okay, so let us move on. So we have a hint there. So 1 volt and 1.8 volt is missing on this motherboard. Okay, so it is going to different places. Okay, so it is coming to this place here, which is 1.8 volt always. So the enable signal straightly comes from the standby IC. So when the standby IC voltages such as 5 volt, 3 volt is proper, when the power is okay, then this IC will execute or will generate 1.8 volt. So the enable signal is straightly connected to the standby IC's power good signal. Alright, so next move on to 1.8 volt. And what is this one? Okay, this is another IC which is this is 1 volt always. Okay, so this is also receiving the same signal from the standby IC as the enable signal for this chip here. So first of all, we need to check whether we have the SPOK, which should be 3.3 volt. Alright, so that should be 3.3 volt. So let me find 1.8 volt here. So this is PU1801. Okay, why is that PU1801? Let me find it on the motherboard. Okay, so I found this IC under the heatsink, so we can check this later. So right now we need to check whether we have the standby power OK signal. So that signal comes to this regulator and goes to 1 volt always regulator, and we need to check whether that enable signal is there, and then we can check the ICs individually whether they are generating the voltage. Okay, so this is the 1.8 volt regulator IC. So pin number 1 is on this side. So pin number 8 is the enable signal for 1.8 volt voltage for generating 1.8 volt. So let me check whether we have the enable signal on this line so that we can confirm whether the standby IC power good is okay, and also we can go back to the 1 volt regulator, so which is this one here. So beside the EC chip, so this is the 1 volt always regulator, so we can check one by one. Okay, so first let me check whether we have the enable signal for this one here, so 1.8 volt. So let me connect the ground. Okay, So we don't have any voltage there. So let me press the power button. Wait a second, I'll just show you the DC power supply as well. All right, okay. So let me press the power button. Okay, checking the voltage, and we have 3.4 volts, so enable signal is there. Checking the output voltage, and we have 1.8 volt. So let me check on this side here. Still the ampere reading is around 10 milliamps, so the board turned off. Let me press it again. Okay, so we don't have 1 volt always. So let me see whether we have the enable signal. So enable signal is on this side here. So on pin number 1 is the enable, so we can check on this point. So let me press the power button, and yes, so we have the enable signal also. So even though we have the enable signal, the voltage is not generated. Okay, so it looks like someone has already replaced this one before. The solder bolts are a little bit thicker. Oh, this is not like from the manufacturer side. Okay, no problem. So let me check the input voltage, so that will be a good measure. So on the coil here we can check the input voltage. All right, so on this point, yes, 7.4 volt, yeah, 19.6 volt, and on the output side, we don't have any voltage. No. Okay, let me disconnect the adapter, and I'll go for diode value. Okay, checking on the coil, so you can see it is 500. Actually we should not get this reading, so it should be like this one, because coil is just a short pad, so the coil has shorted and the resistance value has increased, so that's why it is reading 500. So if I set to ohms mode, you can see it will be around kilo ohms. Oh, the coil came out, so that is okay, no problem. Okay, so the coil was already shorted, so that's okay, no problem. So let me check the resistance on the input side of the IC here, because normally this inductor, the coil will not be shorted. So if there's a problem on the input side only, the coil will be shorted. So maybe this capacitor may have gone shorted, or the IC itself may have gone shorted. But while we were reading the diode value, we saw it was higher, around 900, 0.900. So therefore, I think most probably this capacitor may have gone shorted. Okay, anyhow, let me check it. Okay, checking on the capacitor. Yes, the capacitor on one side we have 1 ohms, 2 ohms. On the other side, yes, 0.03. So 0.3, so this is the natural ground, and on this side it is shorted to ground, so that is 0.7. Okay, so now let me remove the capacitor and see whether the short has gone. Okay, the capacitor is removed. let me check the ohms value again. On this side we have 0 0, so that is natural ground. Okay, on this side, oh, still we are reading 0 ohms. Okay, so I think the problem is with the standby, with the IC here. So even though we have a good diode value on the inductor side, so internal upper and lower MOSFETs are okay, but the IC itself went shorted. So it's very rare, because if the IC got shorted, we will have low impedance on this side also, but we are having a high impedance on the internal MOSFETs, but the IC itself gone shorted. So if you remove this IC, the low impedance will be gone. Okay, so let me remove it. Okay, have removed that. So let me check again. No, still we are having a short. Okay, so why are we having a short on this side? Actually, there's no components on this side. I have removed everything, but still I'm having a short on this side. So is there any capacitors on the other side? Let me check that. Yes, so we have a capacitor on this side, on the back side, so we need to remove this also. Okay, so let me check that. So I forgot to see this one. Okay, no problem. Okay, remove. So let me check it on this side here as well. Yes, there's no short here after. So I think the IC is fine, so there's no problem with the IC. So let me replace it. Okay, so now I have reinstalled the IC on that place. Okay, it looks fine. Yes. Okay, so now I need to replace this inductor here and a capacitor on both sides. So let me replace a good capacitor and an inductor here, and let us check whether we are getting 1 volt always here. Okay, so before that, let me check whether the short has gone. Let me confirm whether the IC is okay. All right. Yes, the short has gone and there is no problem with the IC. Okay, that's fine. So probing to ground, I'm getting 003, and with the IC input side, yes, it is over limit, so that is fine. Okay, so I need a coil and 2 capacitors. Okay, so now I have replaced a new capacitor here and an inductor here. So then now let me see whether we have a voltage on this side. And now the short has gone. So before connecting the adapter, let me see whether the short has gone. Yes, so yeah, it's over limit, so there's no problem. So now let me connect the adapter and see whether we are getting 1 volt always here. So the motherboard, let me press the power button. Okay, so you can see, yeah, now also it is drawing around 22 milliamps. So I think we are not going to get 1 volt. Yes, so I think there's a problem with the IC also. If I check the voltage, yeah, I have 19.65. Whether we have input voltage, enable voltage on this side. The board has turned off. Let me press the power button again. Okay. Yes, we have 3.4 volt enable voltage and also we have 19 volt input voltage. So if we have both voltages, then the IC should release 1 volt. So there's a problem with the IC. Okay. So actually I don't have this model IC with me right now. So I need to order this IC so that I can replace it here. But what I can do now, I'm not going to replace this IC here. So I'll just use this tool here. So this one. So this is a multi-voltage buck converter. So you can see here we have 5 volt, 3.3 volt, 2.5 volt, 1.8 volt, 1.5 volt. And also we have a default voltage as 1.25 volt. So if you don't short any of these pads here, then the voltage output from this buck converter will be around 1.25 volt. So what I'm going to do now, I'm going to lift this one of the side of this inductor and I can connect the output from this buck converter to this line and just check whether the board is working fine. So if you look at the voltage output on this buck converter, so this is 1.25 volt. So 0.25 volt is more for this line here, but it is not a significant high voltage, so it is not a problem here. So what I'm going to do now, so here we have the input. So this is input and we have the common ground, so we can just use one wire for the ground. I'm going to connect it this wire on the 19 volt rail, so I can connect it on this point here from this inductor, and a ground pad I can connect to this capacitor here, and the output voltage to this inductor, and I need to lift one side of the inductor and I can connect it, so then I can check whether the board is turning on. Yes, okay, good. Ground should go to ground here. Okay, so here also this is also a ground, so I can directly connect to this point here, and 19 volts on this line, so the input voltage and output on this lower pad here, not for the inductor, on this lower pads, because this is the output side. Okay. Okay, now I have connected, you see. Yes, on the output side, so you must be careful. So connecting the correct wire, so this is the output. Okay, and the ground wire on the ground potential. Yes, and the positive wire on this inductor. All right. Okay, turning on the power supply. So now let me connect the adapter and see whether we are getting 1 volt always. Okay, fine. So we don't have any enable voltage for uh, this buck converter here, because once we give the input voltage, it will provide the output voltage. So checking with the multimeter, and yes, we have 1.2 volt output. Now look at the power supply. I'm going to press the power button. Wait a minute. Yes, so now you can see the amperes reading around 2000 milliamps, so it is restarting. So I think the board has turned on. So let me connect a mouse so that I can confirm whether I am getting a display. And yes, so I got the display, so everything is working fine. So the problem is only with a 1 volt always regulator here. So if I change the regulator, so I can fix this motherboard. So even I can fix this buck converter inside the laptop, but I am not using this for the permanent use for the laptop. So I use this buck converter only for the testing purpose. So I usually replace the model number, replace the IC here, but for testing purpose I use this buck converter. So this is really a handy tool. So let me disconnect the adapter. Okay, so if the coil voltages are missing on some other motherboards like 5 volt standby or 3.3 volt standby, or if we can't find any regulator IC, so we can use this buck converter. So this will be really handy tool, and it can generate up to 3 ampere maximum output. So just a simple regulator here. So always use this buck converter only for a standard laptop. So you should not use for gaming laptops, because they will require high current output. So this can only output a maximum of 3 ampere. So for this kind of laptop, this will be sufficient. So okay, so we have fixed this laptop. So this how you can use this buck converter for testing purpose, or even you can fix this inside the laptop and give it to the customer. So I'll just order this IC, and I will replace it and give it to the customer. Okay, so I just wanted to tell you something. So we used the buck converter instead of this regulator here, which was regulating 1.0 volt always power. So if the regulator became faulty, first you need to remove this regulator and place the buck converter if you wish, or if you decide to replace a regulator, so there's no problem. So if you look at the pin number 2, so which is a power good signal, so actually they are not using this power good signal from this regulator here. But if you look at some other regulators, for example, if you look at the standby IC, so they are using the power good output from the standby IC as an enable voltage for some other regulator like 1 volt always and 1.8 volt always. So in that case, if you place the faulty regulator on this motherboard, so as the voltage was not generated on the output side, the IC will pull power good to low. So on that case, this signal will not be active. So however, on this motherboard we don't have the power good signal for the 1 volt always, so there's no problem with that. However, in some cases this power good signal will go as the enable voltage for some other regulators here, so it will be in a chain connection. So on that cases, you should make sure you have a pull-up voltage on this line, and also you should remove the regulator IC. So that is an important point to check here. So that's what I wanted to tell you. So thanks for watching, guys.